video, we're going to look at this new Zhaoxin 936D. It's Chinese soldering station. It says on here it's ESD safe. It's variable temperature. It's got your variable temperature control here on the front, where you can set the temperature of the iron. Let's take a look at the build quality of this thing. I just picked this thing up. It was $70 in Canada, so it's not a very expensive for a full temperature controlled iron. It's not a very expensive one. The last temperature controlled iron I had was a Weller. It was very good. I paid about $425, I think. I bought that back in about 1985, I guess. It hasn't worked for a long time because the thermocouple in the iron failed. So I've just been using a cheap piece of junk iron for the last several years, just buying like the $20 ones that don't tend to last that long and throwing them out when it wears out. But I decided I would like something with a little bit more control, because these low wattage 30 and 40 watt irons just don't have much in the way of reserve power when you have to solder something large. So I was in picking up some parts at one of the local parts distributors, and they had this one. They actually had two of them. They had the 936A and the 936D. The only difference between the two is this one has a digital readout to display your tip temperature for what you set it to and what the temperature of the tip actually is. The other one just had a calibrated scale that would give you an approximate, but really wouldn't give you a feedback for the temperature. There was only like $5 difference in the price. The other one was like $65.50, I think, and this one was $70. So obviously the extra $4.50 is worthwhile to get this. A few things that I've noticed on this: the little base solder holder leaves a lot to be desired. When I first got the thing and I was unpacking it, it dropped and it pushed the iron in. This little rubber grip here, it pushed the iron in when it landed and pushed it all the way in like that, and I couldn't get the iron out, and I had to, I've done it again. To retract the iron. When that happened, the iron was hot, so you can see that it actually started to make contact with the back. Normally when it sits in here, it doesn't sit that far down. As you can see, normally there's a space, but if you push the iron in too far, it'll jam, and it doesn't take much force to push it in. Now it's jammed. Now the iron won't come out, and I really have to pull on it. I actually had it jammed worse than that. So just be careful when you put it in there that you don't push it in too far, because you can jam it, and when it's jamming, it'll melt the back. This is just plastic. It has metal on the base down there, so any solder and stuff that drops off it isn't going to melt anything, but the back here is plastic. So just keep that in mind, that it's not a real high-end holder. But let's take a look at the actual iron itself, because this is what does the work, right? So this is the iron itself. It's the same iron for the 936A or the 936D. It's the same iron. It plugs in with a standard DIN 5-pin plug into the controller, and the solder tip simply unscrews. To exchange the tip, take off the cover. These are the tips. They're a hollow tip, and it fits over top of this. I guess this is the heating element, and it probably has the sensor in it as well for the temperature. Again, this is just an adapter collar, so I would imagine that with different tip depths you can probably get a different adapter for it, but it just holds the tip on there like that. Also, we can unscrew this piece here and take the whole entire tip off from the heating element. So that's something to keep in mind, that the iron completely will come apart. It's comfortable to hold. I've only used it a few times. We'll run it through some tests here. I'll get it fired up and we'll see how it's like for soldering some heavy gauge like number 10 wire and stuff. I wanted to get a look at the base unit here for it. So let's take a look at the back side here. We'll see the ratings on here. And they actually say hot air rework station. Zhaoxinpower.com. So I get the feeling that this power supply unit is probably, they probably sell the thing for a hot air station as well, and it just has a different iron that plugs into the front with an air tip on it. It's a 60 watt unit. Notice here it's AC 110 volts. It doesn't appear to have a universal power supply in it. Let's get this thing apart and see what the build quality of the actual power supply is. So it just appears to be held together with just a couple of screws. 4 Phillips screws. That's what appears to hold this thing together. We'll find out when I get the screws out whether it actually comes apart nicely or whether it's also secured or glued or there's tabs or anything, but from the looks of things it looks like it just has 4 screws to hold it together, and it does. And here we go. And this is why this is only rated at 110 volts. I actually like this. It's got a conventional iron core transformer, so there will be different models for different markets. If you live in a 220 country, you'll have a transformer that's rated for 220 or 240. This is 110, 120. So this is actually, I like this. This is a good design. This means that this thing's going to be reliable. If I'd opened this thing up and this thing had a switching power supply in there, I wouldn't have been too happy, because I'm not really that thrilled with switching power supplies, especially things that are delivering a good size load. But this is good. This has got a conventional transformer. On the side over here we've got our power switch, and there's a fuse in here, which is good. That's always a good sign. And our control board. And I mean, this thing is modular. You can unplug it. And here's our control board. Let's just get a close-up here and look at the build quality of this board. And I'll actually even remove, looks like it's just held in place with a couple of screws. So let's remove these screws so we can look at both sides of the circuit board and just take a look at it for build quality. Again, not an expensive iron, but so far I haven't really seen anything that jumps out and says that it's not built very well. Oh, one more screw might help. The third screw here is actually holding the, probably a triac for the heating element to the base. There's no heat sink per se. They're just using the plane of the circuit board as a heat sink. Not that I would think that there's going to be much heat generated here anyway. As you can see, it's a double-sided board. It has both through-hole and surface mount technology. Let's take a look at some of the components on here. I'm just going to unplug the power supply unit from the board, so we can get a look at the board in a little more detail and do some inspecting on here. I see a few things right now that is kind of questioning the build quality right off the bat. Take a look at this capacitor here. That, boys and girls, to me, does not look like a very good solder job. Look at this capacitor here. It's like, hello? Hello? What the hell is that? Like, it's soldered on the back side of the board here. Where is it? It's right here on the end. It's soldered right here. But, oh my God, that's pretty pathetic. When you look at the top side, you would have thought that somebody would have stuck some solder on the top. And then what's this hot snot that they stuck that capacitor down with? I'm gonna go get my regular old-fashioned soldering iron. We're gonna resolder this thing, because that's a disaster waiting to happen right there. And also, not only that, take a look at this regulator beside it. It's exactly the same. Look at the shit here. Look at this pin here. It's all cracked. Ugh. If you buy one of these things, first thing you're going to do is you're going to take it apart and rework that board, because my God, on the 7805 5-volt reference regulator for the circuitry, I mean, that's crap. This capacitor as well. Look at this shit here. I mean, it's like, you know, what are they like, paying someone 10 cents an hour? I shouldn't joke, because they probably are. The optocoupler down here also. Take a look at this. I mean, the soldering on this side of the board is just crap. I mean, maybe it doesn't look like there's some of these have got connections going to them. That there's a trace going to this one here. The other one's maybe only on the back side of the board, but definitely there are traces on the top side. And, you know, it's this capacitor, for example, the positive lead's got a trace going to it. Let me get my iron out. I'm going to rework that thing, and then we'll continue this. Okay, first things first. Let's fix that problem on that capacitor. I'm going to get my magnifying glass down here because make sure I can see what I'm doing. We'll resolder this capacitor. Much better. Same with the regulator IC here. I'm gonna flow this regulator because this one here. And I apologize if you can't see the I can't see the monitor while I'm doing this. So I hope you guys can see what I'm doing. That looks to be a little bit better than what they did at the factory. I'll just take my dental pick and just make sure that there's no shorts in here. Good. So there's no bridges, and that looks to be a little bit better solder job than that they did at the factory. Another one I'm concerned about is this, it's an optocoupler on this little U3 here. We'll redo that one as well. I mean, these connections on the top side of the board here don't look to be very good. And even look at our power input here, our 24 volt AC input and our AC 8.5 volts. These pins here also are leaving something to be desired. You know, this would be a big reliability problem if these pins, you know, let go. The thing would stop working or stop heating. So the regulator looks to be okay. I guess it's not the regulator. This is the temperature controller. This is probably a triac. It'd be a triac to turn the AC 24 volts on and off. That's why we've got the optocoupler here, right? The optocoupler is going to isolate the iron from the temperature control circuitry. So basically, there's a temperature sensor in the iron itself, a thermocouple, or probably a thermocouple, and or a temperature sensitive resistor. It's providing the feedback voltage. So on here you'll have your AC pins, your 24 volt AC for the heater. There'll be a safety ground, and then there'll be 2 pins for the temperature sensor. The temperature sensor circuit is providing feedback through, there'll be an IC on the other side. It's controlling this optocoupler, turning it on and off, and the optocoupler is controlling the gate for the triac, which is going to be over here. That's how these things operate. Just see if there's anything else on the top side here that is questionable. How does that pot look? I don't think there's any connections on the top side for that. It's plated through to the bottom, so it's like an Atmega 8A processor on this thing. From here to be on the back side, so let's just turn it around here. It's an AVR, Atmega AVR. So here's the back side of the board. We'll get a better look at this side here. Check out those connections on the triac. Those don't look to be too bad. I don't see any cracks around here. I'm just looking at this one right here at the bottom of the screen. Inspect that. That one doesn't look to be too bad. That's kind of a flaky connection there, but maybe not. LM7805. And the surface mount components don't look to be too bad, just those through holes. And that actually would be expected because the through hole stuff would have been hand soldered. The surface mounted, this would have been put on by a pick and place machine at a board fabricating plant, and this would all be wave soldered or baked on in an oven. So I wouldn't expect to find, you know, really bad, poor soldering on the likes of the Atmega 8A. It's but it's the through hole stuff that would have been put on. They would have been done by hand after the board was through the manufacturing facility during assembly. That's where the other components would be soldered on, and as you saw, some of the connections there just were unacceptable. Everything else on here looks to be okay. This is the display up top here. This will be for this is the display, the back side of the display. So on here we've got a 3-digit plus a 1-digit display. If you saw it in the other video when I actually had it running, this one tells you your temperature, and it can display in both centigrade or Celsius and Fahrenheit, and this little display over here is a little green, and it just displays an F or a C depending on whether you're in Fahrenheit or Celsius, which is selected by this button over here. You press the button down and it'll switch from one to the other. And let's take a look at the button connection and make sure it's on good. It looks to be through hole and it looks to be soldered okay. I think the problem was just those ones on the top side. More than likely what happened is when the 10-year-old was assembling this at the factory, they only soldered the stuff on the bottom side and didn't bother going through and redoing the ones on the top side, which is really should be done for the best connection. It's probably a plated board, but still, it's a good idea to do them on both sides when you've got a double-sided board, just to make sure that your connection is good. And I know I can hear you guys screaming now, bridge, there's a bridge on that AC 8.5 volt supply, and you're right, there was. I looked at that, I always double check everything, and there was a slight bridge here between these two pins, but as you can see, I'm gonna reassemble this thing. I always double check everything. There is no bridge there. Just so you guys don't get all panicking that I'm gonna blow up this iron, I always double check my work before I assemble everything, and I spotted that one right away. Another one that I spotted when I was looking with the microscope was I'm not happy with this connection here. Might not show as clear on the camera. Maybe I got a good shot of it here, but this one pin here, this is on the temperature control. I'm not thrilled with that, so we'll redo that one as well. Okay, now I'm going to put this thing back together and we'll actually do some soldering with it. So to put it back together, just the reverse order. Drop the faceplate on, the 3 silver screws, and then we've got our 2 plugs. Polarity is not important on this because it's AC, but of course one side does have a ground, and that's the yellow wire. So we want to make sure that the ground wire here is lining up with the ground pin. How we know which one is the ground is obviously the transformer is grounded. It's grounded to the 3-prong grounded, the bond terminal, the green bond terminal here. This is our ground wire. It's also color coded. It's got red paint on it, so you know what direction it goes in. There it is, and the other one only plugs in one direction. Now we can drop the little circuit board back in place. And the top cover just fits into the channel here. Top cover goes back on, and oh, I voided my warranty. There was actually a seal on this thing, so I broke the seal. Oh well. I think that said quality control. that was the quality checking, right? Is that what it says? Looks like someone inspected that in the 11th month of. They stuck a little sticker on there that is now broken, so I guess I have no warranty on this thing anymore, but it's okay. So the unit's back together now. Get the iron, plug it in. Power switch is on the side. We'll turn on the power and we can adjust the temperature. Now when we're adjusting the temperature, it will display the actual temperature that we're setting it to. So if I want to set this to say, it can go anywhere from 392 all the way up to 895 degrees Fahrenheit. So if I want to solder it at 450, for example, I can set the temperature down to 450, and then it'll revert to the tip temperature. Now, as this tells me the heating element is on, and the tip temperature will rise to 450 degrees, and then this light will start to flicker when it gets there. Now that the heating element is off, as the tip temperature drops, as you can see, now it's going to pulse the element to keep the temperature at 450 degrees. So 450 degrees is not going to melt this solder because this is 60% tin solder, and it needs a little hotter tip temperature than that to melt. Press the tip temperature button and it'll display the temperature in degrees centigrade or Celsius. Again, old school, I work in Fahrenheit, and I normally operate with a tip temperature of about 688 degrees, 690 degrees, so whoops, there we go. That's usually where I operate, around there. So now it'll revert back to the tip temperature as it heats up to operating temperature. Now I'm thinking that the temperature probe is probably on that heating core. So even though the heating core is at 688 degrees, it's going to take a few seconds for that heat to travel down to the tip. But it does warm up pretty quick, and as you can see, it melts solder nicely. Let's actually do some solder work with this thing. show you how good this thing actually works. So this is a big board. This is an old dead board out of a plasma. This is a Z sustain board. The actual IC on this thing is cooked. I want to try and say take out one of these big coils, because this is going to take a fair bit of heat. So I'm going to turn the iron up a bit, because at 688 degrees I think I'm going to need a little more. Maybe bring it up to about 800 degrees, because I know that I'm going to need a little more heat just to get into the size of this wire to release this, and I should be able to remove those inductors relatively easily with a hot iron. Well, I'd say for removing a heavy coil like that, that's a fail. But again, this is about a number 10 wire coil, and you need an awful lot of heat to remove something like that. I wouldn't try that with a regular iron anyway, because just the amount of heat required. I was able to get a lot of the solder off, but that's a fail. But you know what? You're never going to remove one of those in the field anyway, because something like that is never going to fail. So let's give it something more realistic to do, like changing the capacitor. So I've taken my tip temperature back down to my normal 688 or 700 degrees. I usually run around 688. You'll hear it beep. That tells me it's gone back into temperature read mode. Let's try removing something a little more realistic than a big coil, like a capacitor. No problem. Handle that job, no problem. Let's try it for some fine work. Well, we'll try resoldering the surface mounted chip on this. This is a dead board, but we'll resolder the chip for the heck of it, eh? So first we'll prep it. We'll just put some flux on there. I know I'm just kind of going through the motions on this because this is a dead board, so I can't really test it, but I want to see how this built-in tip that comes with it performs when working on fine work like surface mount components. Did a good job of bridging them. Let's see how we can pull the solder off here. And I will just throw a little bit more flux on there and see if I can clean those connections up a bit. Just using the iron. Of course, that's the job of the flux, is to flow the solder where you want it and not where you don't want it. Camera doesn't focus very well close up, but with my microscope,
I would say that that's a pass.
yeah, there's no bridges on those, so for fine work it seems to be fine. It's nice to have a controlled temperature tip that stays where you set it. For that, this works fine. Let's try the solid wire test. So for the solid wire test, I'm just going to take a piece of number 10 solid copper wire. We'll just twist the ends together and we'll attempt to solder them with this iron. Now, of course, when dealing with solid copper, you need to put a fair bit of heat in. So this will pretty much push the iron to its limit as far as its ability to transfer heat. I'm just going to kind of prop this up here on my workbench so that it'll stand up, sort of. And then we can proceed to see how well I can flow some heat into that. I've got my iron still set at 688 degrees. We'll see how well the temperature transfers into this wire. As you can see, it is holding the temperature pretty good. It's not drifting. It went down to like 686 there for a bit. It's holding the temperature right where I put it. It is heating up. It's taking a while to do this. This is kind of the acid test though for a small iron like this. Normally if you were soldering big wires like this, you'd be using like one of those Weller 150 watt guns to put the kind of heat you need to get into these number 10 copper wires, because a lot of that heat is just being sucked into the wire. But it is soldering it. It is heating the wire up. It is heating it up to the melting temperature, and it is holding its temperature. I mean, I am not seeing any drop here on the digital display. Initially, when I put the iron on there, it dropped down about 2 degrees, and then the heating light came on solid, and it brought the temperature right back up. And I would say that, you know, it took a while, but let this thing cool here for a few seconds so I can touch it. As you can see, it's right up to temperature again. It's holding the temperature. That's how it normally idles, as it sits there with the light flashing on and off momentarily. It is holding its temperature, and that connection looks to be pretty solid. Getting close here. Camera in a little closer so you can see it. That connection looks pretty good to me. It took a while to get it hot, but certainly it did heat it up, and it did make a good connection. So it's an inexpensive iron, but I think for what it cost, you know, the $70 that I paid for this thing, we'll see how it lasts in the long term. I'm not going to be using this thing day in and day out. I think if you were someone in the business and you needed to run your soldering iron 7 days a week, 12 hours a day, maybe investing in a Weller or a Cooper iron might make it be a worthwhile investment. I think for hobbyists, this is going to be just fine. For myself, this is going to probably last me for many, many years. The construction quality looks to be pretty good. I don't know about the tips. I'm going to check them out. They should be available at the local supplier that sells them. Look to be a pretty standard tip, and I don't think the tips are going to be that costly, although I didn't price them out when I when I bought it. He did tell me that he did have different styles, so this is the one that comes with it. It's a fine tip. He did have a chisel tip and other tips that were available for it. Overall, I think that, you know, for what it costs, this is probably a pretty good buy. Keep in mind, if you buy one of these things, you're going to want to take it apart and just take a look at those connections that I pointed out that were certainly less than desirable. But take care of that, and this thing probably would be a good investment for the money. As I say, $70 Canadian. You can probably pick this thing up for $40 or $50 US, I'm thinking. Seems to be a pretty good buy. I'll give it a thumbs up. Just one thumbs up though, not two. Two thumbs up if it was a little better build quality, but I think that once we've taken the thing apart and dealt with the problems, it looks like it's going to be a winner here on my test bench. Thanks for watching.